Hello, lovelies. You're welcome to yet another interesting class. In this lesson, you'll learn some cool things about an important area of mathematics called algebra. Just like in arithmetic, algebra uses the four basic mathematical operators, which are addition, subtraction, multiplication, and division. In addition to these, algebra introduces a new element called the unknown. The unknown is represented by any letter of the alphabet. You can use algebra to do some nice things. Algebra can be used to figure out what you don't know from what you do know. If, for example, we tell Adamu to think of a number and add 2 to that number, then tell us what he got, we can figure out the number Adamu thought of using algebra. How? Let's use x to represent the number Adamu thought of. We told him to add 2 to that number, right? So let's add 2 to s so that we have x plus 2. We asked him to tell us what he got. Since Adamu is not physically present with us to tell us what he got, let's use y to represent what he got. You see, this is a simple algebraic expression. Let's say Adamu got 5, so we replace y with 5. All we have to do to solve for x is to take plus 2 to the right hand side. When plus 2 crosses the equal sign, it will turn to minus 2. So don't forget, anytime plus crosses an equal sign, it turns minus. Don't forget that x is what Adamu thought of. Let's solve for x. Plus 2 will cross the equal sign to the right hand side so that we'll have x is equal to 5, then minus 2. 5 minus 2 is equal to 3. So the number that Adamu thought of is 3. Now we have a code. The code is that anytime Adamu tells us what he gets, to figure out the number he thought of, we'll minus 2 from that number he tells us. So if Adamu tells us that he got 10, we'll minus 2 from 10, and we know that Adamu thought of it. Pretty cool, right? So, algebra is used to figure out what you don't know from what you do know. In this video, you'll learn how to remove brackets from algebraic expressions. You would also learn how to factorize algebraic expressions using common factors, factorize larger algebraic expressions, and factorize algebraic expressions by grouping them. Before we go on to learn how to remove brackets from algebraic expressions, let's review some operations with the basic mathematical operators. Note that the multiplication sign is also bracket in algebra. The first operation you need to know is plus times minus is equal to minus. Next, minus times minus is equal to plus. Next, plus divided by minus is equal to minus. Now I want you to answer this. Minus times plus times minus times minus times minus is equal to what? If plus was your answer, then you're correct. Minus times plus is minus. Minus times the next minus is plus. And plus times the next minus is minus. And minus times the last minus is plus. So, the answer is plus. Alright, it's time to learn how to remove brackets from algebraic expressions. If you're asked to remove the brackets in 6 times 3a plus 4b, use the term outside the bracket to multiply each term inside the bracket. Again, use the term outside the brackets to multiply each term inside the bracket. So what is the term outside the brackets? 6. And what are the terms inside the brackets? 3a and 4b. So this means you would use 6 to multiply 3a and you use 6 to multiply 4b. 6 times 3a is equal to 18a. 6 times 4b will be 24b. This is the required answer. Now let's take a look at another example. If you're asked to remove the bracket from 7c minus 2 times 7c, remember the term outside the bracket will multiply each term inside the bracket. So what is the term outside the bracket here? 7c. And what are the terms inside the bracket? 2 and 7c. So to remove the brackets from this algebraic expression, we would use 7c to multiply 2, and then we also use 7c to multiply 7c. 7c times 2 is equal to 14c, and 7c times 7c is equal to 49c squared. How? 7 times 7 is 49 and c times c is c squared. Here is another example. Remove the bracket from 3a plus 2 times a plus 2b. Now I told you before that if you are to remove the brackets from an algebraic expression, use the term outside the brackets to multiply each term inside the brackets. So what's the term inside the brackets? Yes, a plus 2b. And what's the term outside the brackets? 2. So we'll use 2 to multiply a and then to multiply 2b. 2 times a is equal to 2a, and 2 times 2b is equal to 4b. Next, we'll bring down the plus and then we'll bring down the other 3a. Notice that 3a and 2a has something in common. What's that? A is common between 3a and 2a, so we can add them up. 3a plus 2a is like saying 3 oranges plus 2 oranges, and that's 5 oranges. So 3a plus 2a is 5a, and then we bring down our plus 4b. This is the required answer. Since you have learned how to remove brackets from algebraic expressions, now move on to learn how to factorize using common factors. So what is a factor? A factor is a number that can divide another number without no remainder. So what is the highest common factor of 9 and 12? By this we mean a number that can divide 9 and 12 at the same time without no remainder. So in order to find the highest common factor of two numbers, find the LCM of those numbers differently. So first, we'll find the LCM of 9. Let's tabulate it. We have 9. Can 2 go into 9 without no remainder? Of course not. So let's check 3. Can 3 go into 9 without no remainder? Yes, 3 into 9 is 3. So what other number can go into 3 without no remainder? Of course, 3. 3 divided by 3 is 1. Next, we also find the LCM of 12. What's the simplest number that can divide 12 without no remainder? Let's start with 2. Can 2 divide 12 without no remainder? Yes, of course. 2 divides 12 will be 6. 2 into 6 is 3. And then 3 into 3 is 1. Here we have 3. Is there 3 in the side of 12? Yes. So the HCF is equal to 3. We go to the next number 3. Is there another 3 in this side? Of course not. So the highest common factor of 9 and 12 is 3. Here is an example. Factorize 12c plus 6d. Note that there is no bracket in this expression, so we call this type of expressions linear algebraic expressions. So how do we factorize this? First, look for the HCF of the numbers that are present. In this case, we'll find the HCF of 12 and 6. The HCF of 12 and 6 is 6. This is the number that can divide 12 and 6 without no remainder. So, to factorize 12c plus 6d, we'll write out plus 6. Next, we use 6 to divide 12c and 6d. 6 into 12 is 2. So 6 into 12c is 2c. 6 into 6d is 1d. 1d is the same thing as d. So we have plus d. This is the required answer. Simple, right? Let's take a look at another example. Factorize 3ab minus 6ac. The first thing I told you to do in order to factorize this type of expressions is to look for the HCF of the numbers. So look for the HCF of 3 and 6. What's the HCF of 3 and 6? 3. Notice that A is common between AB and AC. So we'll write A out. Next, we use 3A to divide each term. So 3A into 3AB is B. Minus 3A into 6AC is 2C. How? 3 into 6 is 2. And A, we take out A and then we have C. So 3A into 6AC is 2C. This is the required answer. Alright, here is an example. Factorize 2x times 5a plus 2 minus 3y times 5a plus 2. You will immediately notice something between the first term and the second term. What do you notice? The terms inside the bracket are the same. 5a plus 2 and 5a plus 2 is same. When you have this type of case, what you do is you pick one of this expression. So let's write it out. We have 5a plus 2. When you have done that, the next thing is you pick the terms that are outside the bracket of the two terms. So you open brackets, 2x minus 3y. And yes, this is the required answer. Alright, let's take factorization by grouping. If you have some of these students in a group and I told you to tell me the number of boys and the number of girls in this group, the easy way to do that is to bring the boys together and the girls together. If, for example, we replace these boys with algebraic terms like cx plus cy plus 2dx plus 2dy, we can factorize these by grouping. How do you solve this type of expressions? You notice that there's something common between the first term and the second term. C is common. So what do? We bring C out. Now C into cx will be x. So we write bracket x. Then we have plus C into cy, it's y. Also, in the third term and in the fourth term, we find out what's common. 2d is common between both terms. So we'll bring out 2d, and then 2d into 2dx will be x. 2d into 2dy will be y. Notice that the two terms inside the brackets are the same. Just like we did when we factorized larger expressions, we'll take one of these factors out. So you have x plus y And the next thing you do is that you bring down the terms outside the brackets. What are the terms? You have C plus 2D. We can put this in brackets also. This is the required answer. Alright, we have come to the end of this lesson. Until next time, bye bye.